What's up, YouTube? It's your favorite math teacher, Mr. Stevener, coming at you with another video. This video I'm excited about, okay? This video is complex equations like this, where you got variables on both sides and you have to be able to solve them. What are you doing? Sorry, I'll go. No, you don't have to go. Come back here. I just didn't know you were ready to already get in the video.
Yeah, I want to see what you're excited about. I want to know.
Oh, I'm excited because we're going to be learning complex equations like this, right? If you haven't mastered the basics yet, go hit that I. Watch the process behind this. But right now, Tommy, this video, we're going to concentrate on what to do to make that guy look like that.
There is no way those are the same thing.
I promise they're the same thing. And I'm going to teach you today how to get from that complicated one to the not so complicated one. So without further ado, what do you say?
Let's get into it.
All right, let's get into it. So, first off, Tommy, you'll notice that that first one looks kind of complicated, doesn't it?
Just a little, yeah.
It does look just a little. Keep in mind, our goal is to make that thing turn into 3x is equal to 9. I'm going to write that over here. I promise you, we're going to get to that.
Really?
We really will. So, watch carefully the process. First off, you guys have to understand our goal is still the same. Okay? We still have to find that variable. Okay? We still have to find that variable, that x. Okay? Problem is, when I say split it down the side, right, and treat it like a balance, do the same things to both sides, it's really hard to get x by itself when there's multiple of them, huh?
Yeah, I was kind of thinking that. I was like, I don't know what to do.
I know, that's why I was figuring it might be better if I showed you. So, first off, you always want to simplify. Here's the first thing you want to do. You want to simplify both sides, okay? And here's what I mean by that. Notice this side, it's a 5x minus 10. That guy is simplified, okay? It's simplified because there are no like terms, okay? Like terms are either variable terms or non-variable terms. And here's what I mean by that. So this is a 5x. If this was a negative 10x, yes, you could combine them. But it's not. It's a negative 5 and a negative, or negative 5x and a negative 10. You cannot combine them. Okay, we'll talk more about that as we go. So that's the first step, simplify. This side, you'll notice, is simplified. What do you notice about the left side, Tommy?
Well, it's not, because there's lots of stuff going on. Lots of stuff, yeah.
There is lots of stuff going on, and there's lots of steps you have to do. Okay, you're first going to start with distributive property.
Oh, wait, yeah, I think I know what that is.
I'm glad you think you know what that is. That's this part where we're going to take this negative 2, and yes, it's negative. That sign has to go with it, and we are going to multiply it by each term in these parentheses. Okay, that's where we're going to start. It's called distributive property. This is not something you're going to see every time in an equation, guys. This is just this particular complex equation looks like that. Okay, that's where you just have to simplify as far down as you can so it looks like this side. You ready, Tommy?
Yeah, keep going.
So what is negative 2 times 3?
Negative 6.
Good. And then negative 2 times negative x.
A negative times a negative. Isn't that a positive?
It is a positive, so that would be a positive 2x, right? You're just combining them, really. 2x.
Oh, okay.
Don't forget about your 5. That's here, too. All right, is that simplified all the way yet?
No, it's not.
Why not?
I don't know. I just didn't think it was.
Oh, it's not because you have some like terms that you can combine. Like, can you combine anything with 2x?
Well, no, it's the only x term.
It is the only x term. But the 5 and the negative 6, I can combine those. So what's 5 take away 6?
See, $5 take away $6. I got negative $1.
You got negative $1. You're right. So this is negative 1 plus 2x. Okay, so now are both of my sides, simplified?
Yes, they are simplified.
They are simplified in the sense that I can't combine any like terms, right? No like terms left. See that?
Yeah, gotcha.
All right, so with that in mind, this is where people get really confused, okay? So this is the second step, and I'll be honest, tune in. This part can be tricky. Do you want to know?
Well, yeah, I'm just waiting. Just do it.
Oh, sorry, just do it. Okay, so first off, you have to decide, okay? This is kind of a visual thing. You want to move one of the x terms, either this guy or this guy, across the equal sign. Okay, you want to move it somehow. But you have to decide which one you want to move. And this just takes some problem solving. It's not hard, it just takes some thinking. You with me?
Yes, go ahead.
Okay, so you're going to move it by doing the inverse operation of the whole term. Okay, what I mean by that is you want to move the entire thing, not just get rid of the 2 like we did in the last videos and that you'll see later. Not just get rid of the 2 and turn it into a 1. I want to move the whole term so that x's are all on one side. Say, okay, that's your goal. You want to get the x's all on one side. So x on one side. Okay? So if I want to get x on one side, I have to move the whole term.
Whole term. Got it. All right.
So if I'm looking at this, I'm noticing if I move this 2x, getting rid of it by doing take away 2x, right? That's the inverse operation. It's the exact opposite. 2x take away 2x is what?
0?
Exactly. So if I take away 2x on this side, I'm noticing this is going to be 5x take away 2x. Those are like terms. I can do that. That's going to come out positive. Or I can do it the other way, where I end up doing take away 5x from this side and 5x from this side, and this will just be 2x take away 5x, which is negative. So which way would you rather do it?
I don't want to deal with negatives.
I know, you don't want to deal with negatives. So that's one way to look at it. You want to try to do one side from the other so you don't create negatives for yourself. You with me?
Yes, got it. No negatives. Pick a side. Pick a side.
Pick a side. So I'm going to do negative 2x. Notice, keep in mind, that's getting rid of the whole term. And I can take away 2x because those are like terms. Are you with me?
Yes, 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 yes.
Okay, so we do the same on both sides. Remember, whatever you do to one side,
you got to do to the other.
Okay, cool.
I was excited. I knew it.
All right, fair enough. So I'm going to keep going. This is negative 1 left on this side, correct?
Yeah.
And what's 5x take away 2x?
3x.
Good. Minus 10. Now what? Now it just looks like a regular equation. That video up there that I was talking about.
Why do you keep pointing to the ceiling?
Remember we talked about this.
Oh, yeah, the eye. Oh, yeah. Okay. Go click on the eye. What?
Nothing. So I want to get rid of, or get the x all by itself, right? So I got to get this term by itself. To do that, I'm going to get rid of the negative 10 by doing the opposite of it, the inverse operation. I'm going to add 10 to both sides, right?
Yes.
Okay, what's left over here?
3x.
Good. And what's left over here?
Negative 1 plus 10, 9.
And notice, what do you notice?
No, they're different. That says 3x is equal to 9, and this says 9 is equal to 3x.
Ah, good question. That's really kind of awesome that you're noticing that, Tommy. So you think these might be different?
I'm not sure.
That's great. So keep in mind, guys, it actually does not.
What's that?
I got a text message.
Oh, sound like R2-D2.
I know, it is. So you can actually switch these if you want. 3x is equal to 9. It's the same thing. You can switch it back. 9 is equal to 3x. It doesn't matter as long as you keep what's on one side the same in other.
Ah, I didn't know that. Cool. Nifty. So wait, we did it. We made it the same thing.
We did make it the same thing. Isn't that kind of cool? Notice we made it to 3x is equal to 9, just like we said we would do.
Wow.
And now we can solve. I'll just show you real quick. Remember how earlier I said we want to move the whole term, so we took away 2x? Right here?
Yeah.
Now you don't want to get rid of the whole term because that would get rid of x. You don't want to do that. Now you want to get x by itself, which remember was our original goal. The problem is we had x's on both sides.
Yeah, I know that.
Okay, so now I'm going to divide, because remember, this is inverse operation still, until x is by itself. 3 and x next to each other means
multiplication.
Exactly, because the default of an equation is always multiplication. If you don't see an operation, you know it's
multiplication.
Exactly. So I'm going to divide by 3, because keep in mind, 3 divided by 3 makes 1, right? So now I have 1x, or x, all by itself. But what you do to one side,
you do to the other.
So what do I divide this side by?
3.
Good job. And 9 divided by 3, or 9 divided by 3 is?
3.
Good. So x equals 3. And I could take this, I could plug it back in, and believe me, if I put 3 for both of those, they would be equal. It would be perfect.
I want to see it.
Well, it's really easy, because notice if this is a 3, Tommy, 3 minus 3 is 0. That means this is 2 times 0, right?
Yeah.
So that means this is 5.
Yeah.
And if I put a 3 right here, that's 5x. That's 5 times 3 is 15 minus 10. What's 15 minus 10?
5.
So 5 is equal to 5.
Oh, wow, that's kind of cool.
Exactly. Let's do one more, Tommy. I appreciate you. I'm just going to real quick show you what it would look like again if we had a different type of problem. I appreciate you sticking with me, Tommy. Here we go. Look at it. Here we go. What if we had something like 4 take away 9y is equal to, let's go 18y plus, what do you think, Tommy?
Let's go with plus. Hmm. 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 96?
Wow. Do you want to do plus or minus?
I want to do minus, yeah. Minus 96. 96.
Are you sure?
Yeah.
All right, there you go, minus 96. We don't know if this is going to come out even. Doesn't matter. You'll notice our first step we talked about was to simplify both sides, right? Now let's look. Are both sides simplified? Are they there?
Let's see. Oh yeah, there's no like terms to combine, so yeah.
You're right. This is no like terms to combine, so they're good. Perfect. So now we just got to move the y to one side. Okay, so which one do you think would make more sense to move?
The negative 9y, because it would just be adding 9y.
Exactly. So let's split this side up. Notice I want to move this guy. I'm going to move the whole term, right? Not just plus 9. I'm moving the whole term to both sides. Okay? So now I'm left over here with 4 is equal to 27y minus 96. Now what?
Still gotta get y by itself.
Right? You got y to one side. Now you got to get y by itself. So let's add 96 to both sides, right? That cancels this. And you get 100 is equal to 27y. Then what would you do?
Divide by 27.
Good. Divide by 27 by both sides, and you would get y is equal to 100 over 27. We don't know what that is, but it doesn't matter. You getting this process, Tommy?
Yeah, I think so. I tell you what, that last video really helped. That last one. So go watch it.
You think they should?
Yeah, it helped me.
Oh, good. Hopefully this helps, guys, because you're going to see some tricky ones where you'll have a variable on both sides. Okay? So remember, simplify.
Simplify. Yeah. Like terms, combine them.
Yep, combine them on both sides. Then start moving whole terms around by doing the inverse operation, right? And then solve. Basically, your goal, guys, is to get it into an equation that looks like this, that's manageable, something you can do. You guys have seen 27y minus 96 is equal to 4 before. You've seen something like that. You can solve that. So your goal is to make this look like that by just moving terms around.
And you can do that?
You can do anything to an equation as long as you do it to both sides.
Really? That's kind of cool.
Yeah, I don't know if you'd want to do that, but you can.
Okay, thanks, guys. Thanks. I think you're cool.
I think you're pretty cool too, Tommy. Hopefully this helped, guys. If you have any questions, feel free to subscribe. You know we are here
To help you. Yeah. Okay?